All right, here we are. So last week we talked a little bit, we're going to be talking about chemistry. We talked a little bit about, the basics of chemistry. You have no life without water. The elements that are involved in life, no chips, nitrogen, oxygen, carbon, hydrogen, phosphorus, sulfur. And we talked a little bit about atoms and molecules and how those work up to be building cells. So we're going to be spending more time here and here in kind of basic chemistry. And then maybe next week we're going to combine these, and this might spill over into the lecture after that. We're going to talk about organic molecules and how those make up cells next week. So now we're just talking about chemistry, basic chemistry, so like physical chemistry and how it relates to life. In this lecture, we're going to define matter, go a little bit through the periodic table, talk about the structure of an atom / elements, and then get into just some subatomic particles and quantum level stuff as well. So shouldn't be too long here. So what is matter? This is basically anything that takes up space. Anything that takes up space. That is defined as matter, which is actually kind of a fallacy also, and we'll talk about what that means. And fallacy just means it's not really true. So like I said, really it's anything that takes up space, and all matter is condensed energy. Condensed energy. So when the universe first exploded into existence, some of that energy condensed, like water condenses into liquid from gas. Energy condenses into matter. And some of you might be familiar with this. E equals mc squared. Energy is equal to mass times the speed of light squared. So energy and mass are the same thing. If you just multiply it by this constant squared. But the speed of light also, it really isn't a constant. The universe just gets trickier and trickier. And there's three main types of matter. Kind of getting a little goofy here, a little wonky. This was, of course, developed by Einstein. Okay, so there are three different types of matter that we can talk about. We'll just talk about it with water. So we can have, very simply, a solid. So this would be an ice solid. That'd be an ice cube. We can have ourselves like a little beaker. We can have a liquid. And we can have that same beaker again. And let's say we've got some fire applied to it. And so now some of this is becoming water vapor. And so now we have a gas. So gases are not defined. Not defined. No definite shape. No defined shape. They will expand. They're tiny molecules bumping into each other. No defined shape. This is defined by the container. Take the shape of its container. And these have a defined shape, like we just talked about with snowflakes. They're always six-sided, 6-point. So there are three states of matter. You can also have a fourth, which is, it's called a plasma. So you got your gas particles, and then you've got, some of these atoms have lost their electrons. And so now you have electrons floating around, which are negative. And then you have the positive atoms floating around. So we can also have a plasma, which is a gas where the atoms lost, where some atoms lose an electron, or maybe two. Who knows? Okay, so that's a plasma. For example, the sun has a lot of plasma in it. It's so hot that the electrons are just falling off those atoms. Pretty crazy. All right, so that's just a little bit about matter. We could talk way more in depth on this, how this all came to be, what each one of these is, but this is not a chemistry class. I would love to talk about all that, but we don't have the time. Okay, so we got this little thing. I had a picture of a periodic table. Now I don't know where it is. That's okay. I don't. Oh, let me actually get it. Let me get it here, because I do wanna pull it up for us. Sorry about this. Here we go. All right. So we talked a little bit about this. We have different atoms, and an atom is defined as, it's like the smallest unit of an element with those properties. Yeah, smallest, an atom. We already wrote this down, but we'll write it down again. So an atom is the smallest unit of an element that has the properties of that element. So it still reacts to things the same way. Really, you can think of an atom as just an element. It's a single unit of that element. Very easy to think of. And so this is the periodic table of elements. So each one of these could also just be an atom. You could have a hydrogen atom, you can have a helium atom, so on and so forth. And really with life, the main ones that we're going to be looking at, so I'll go up to 20. So these are the main ones that we're going to be looking at that are involved in life. Not all of these are heavily involved in life, but these are the main ones. And then we got some extra ones in here, like iron, for sure, big time. Zinc, for sure, big time. And there's some other ones sprinkled throughout here. Iodine, I'm not making a full list here, but we talked about that also. I just wanted to kind of look at this periodic table with you because it's got some information, and we're going to go through what all of that information means. Okay, so this is a periodic table. It's highly organized. Just to give you a little clue, like this period, so here, like these, all kind of react the same way. They have this similar properties because they all have one electron in their valence shell, or their outer shell. Whereas these over here also all react the same. They all have a full valence shell. These are actually called your noble gases. Noble, that's the word, noble gases. They don't react. They're non-reactive. Non-reactive. Nobles, they don't interact with the riffraff, the peasants. They kind of stick to themselves. And that's because, they don't need to interact with anybody else. They're, hoity-toity. They're in the upper class of society. So they stick to themselves. These noble gases also stick to themselves. Helium, neon, argon, so on and so forth. These don't interact with other things because they have a full electron valence shell. Point of all this is the periodic table is arranged and organized in a way where the atoms in this period all share similar properties. So oxygen, sulfur, selenium, they all share similar properties. Nitrogen, phosphorus, arsenic, all share similar properties. Carbon, silicon, germanium, all share similar properties. We are carbon-based life forms, there's a possibility that there could be a silicon-based life form because it is an atom that can also bind to 4 other atoms. Pretty interesting. Okay, I wanted to give you that little tidbit about the periodic table. Okay, now let's get into the structure of an atom, and we're going to build a helium atom. Actually, let's just start with a hydrogen atom. It's the easiest. Hydrogen looks something like this. In the middle, we've got ourselves a proton. So we're going to build a hydrogen atom. This is a hydrogen atom. We'll build a couple of these. We'll build 3 of them. And I'll just do it like this. All right, so we got our proton in the center, and then the number of protons and electrons in an atom always equal each other unless under some certain special conditions, which will change the properties of the atom. It can happen. So our hydrogen atom, and then it's got 1 proton and 1 electron. So it's got 1 proton and 1 electron. Electron. All right. And we usually kind of draw these as like this electron like being in this orbital. It's on this orbital around the atom like so. Adjust this a little bit. So that electron kind of orbits the proton. That's a hydrogen atom. Very simple. Okay, so let's move on to the next one. Let's build a helium atom. We'll draw this in. We'll keep this also in blue. This is a helium atom. Okay, so it's going to have 2. It's the second element. We go up here. It's the second element right there, number 2. It's going to have 2 protons, which means it will also have 2 electrons. Pretty nifty. All right, so we got 2 protons. Okay. And we're also going to have 2 electrons. Let's draw our little ring around there. Make it a similar size. It's not going to be perfect because I'm not perfect. And neither is biology. Okay. And then we're going to have our 2 electrons in that orbit. Okay. We're leaving something out here though. So helium, its atomic number is 2, but this number here is the atomic mass, right below that. So here hydrogen, its atomic number is 1 and its atomic mass is 1. Okay, we got 1 proton, so its mass must be essentially 1. The electrons don't really weigh anything, we'll talk about that. So here we're missing 2 particles. And those particles, you may know, are called neutrons. Like so. Boom. So that's a helium atom. We'll do one more just to see if this is starting to sink in, and then we'll kind of break these particles down and talk about what they are. Okay, the next element is lithium, number 3. So lithium. So it's number 3, which means it's going to have 3 protons and 3 electrons. Pretty nifty how that works. I'm just going to recopy this ring. Oops, what's going on? Guess I'm not going to recopy that ring. Okay. All right, well, let's draw in our protons then. Let's draw this up here. So lithium. Lithium. We'll draw in our 3 protons. Maybe something like that. And then we'll draw in our ring. Baby, what are you doing to me? Like so. Okay. And now we will draw in our 3 electrons. Like that. Beautiful. And now all we need is our 3 neutrons to kind of seal the deal here and make this a beautiful little lithium atom. It's not perfect. I could do better. And I did better. Okay, so that's lithium. All right, so let's just list out what each one of these is made out of, just so we can have that here under our notes. So our hydrogen atom, so it is made out of protons. It's also made out of electrons. And really, it's only made out of one of each of these. So it's made out of one electron, and it is made out of one proton. Okay? Whereas the helium atom is made out of how many? Two, oops, not plus two. It's made out of two protons. It's made out of two electrons. Two. And last but not least, it is made out of neutrons. And it's made out of two of those. Beautiful. I'm just going to copy these over just so I don't have to type that again. And with lithium, all we got to do is change these to all three. It's made out of three protons, three neutrons, and three electrons. All right, that all checks out. Math all checks out. And we could just continue this ad infinitum all the way through the entire periodic table, though it gets a little confusing. And this I kind of drew inaccurately. Let me actually fix that just so I don't hate myself. If we're kind of going to stick with our valence shells, the first shell here can only hold 2 electrons, according to the Bohr model, and we'll talk about that. Then there would be a second shell that forms, which could then hold this electron here. Okay. Beautiful. Sorry about that. Wanting to be more accurate here and less confusing. Okay, so now let's talk about the properties. Let me see how we're doing on time. I can't actually see. Let's talk about the properties of these particles and then briefly talk about quantum particles. Not too long. So we got protons. We've got neutrons, and we've got electrons. These are both bigger and they weigh more. Okay? So these are you can just see that in the way I drew them. These are bigger and weigh more. They have more mass. Right? They got more oomph to them. Electrons are smaller. These are smaller. And they weigh something like 1/2000th of a neutron or proton. So neutrons and protons essentially weigh about the same. They weigh the same. Electrons essentially contribute no mass to the atom. Okay, so we got charge. Let's put charge here. Let's put charge, and then let's put mass. We're gonna make a little table. So the charge of a proton is positive. It's +1. Neutron is neutral, 0. An electron is -1. It's got a negative charge. As far as the mass goes, we can essentially just think of protons as weighing 1 atomic mass. Neutrons also weigh 1 atomic mass, and we can think of electrons as essentially weighing 0, just for simplicity's sake. They do have a mass, but it's 1/2000th of a proton or neutron, which is already an incredibly small mass. All right, it's pretty crazy. So this is why electrons and protons always are evened out unless we have an ion, because they have this charge that attracts them. All right, just really quick. These guys here are made out of quarks. Quarks make up protons and neutrons. I think that's all I'm going to talk about. So we can take these are larger, we can smash them up. We can smash these up and then look at the scattering the explosion, the accident, and piece together what they're made out of. So it's like if you took two cars and you smashed them together to figure out how an engine worked. Like if it was all closed up and you couldn't get in there, you see. Oh, here's, I don't know, the piston. Here's a gasket. This is the stuff that makes up an engine, and the engine makes up a car. Electrons, on the other hand, they aren't made out of anything that we know of. These are eternal, and they don't die, they don't go away, they don't decay, and not made of another particle. Pretty crazy to think about that. All the electrons that came into being in the universe are still here. They never went away, they never went anywhere. Pretty crazy stuff. One other last little point is, we talked in the beginning that anything, mass is defined matter. So we did that. We did the periodic table, did the structure, did the subatomic particles, did the quantum. Okay, I did everything here, checked all this off. I feel good about that. Mass or matter is anything that takes up space, and all matter is condensed energy. Takes up space. Well, if you actually look at these, if this is an atom, this is an atom, it's mostly empty space. You only have these tiny little particles in the center that really take up space. The electrons are whizzing around. They don't actually orbit like this. Let me see if I can give you a little picture of this. Interesting thing about atoms. Yeah, I got a little image here for you. This stuff's really wild and kooky. They don't actually orbit like this model, like I drew them and like we think about them. So this would be helium, these would be the protons, neutrons, and electrons. Electrons form in a cloud around the nucleus. And these little dots represent probability of where you would find that electron. It doesn't really make a lot of sense. Like when you get down to the atomic level and the quantum level, things get really strange. And if you were to then define where that electron is, you couldn't know anything else about it because you've now changed it. You have to disrupt it and disturb it in order to measure it, which is a very fascinating concept. I think, yeah, okay, so if you look at these are mostly empty space. So this idea of you can't push into your fingers or go through the wall is really kind of interesting when you think that all matter is made out of mostly empty space. And it's the repulsive forces of the electrons being negative on the outside pushing against other electrons that keeps us from walking through a wall. Otherwise, we would be able to walk through walls. So it's really the repulsive force of electrons that makes things feel solid and define their own space. But an atom itself is mostly just empty space. Okay, I hope that's interesting to you. I think it's fascinating. Yeah. Okay, I'll shut up. Just kidding. I'm going to actually be back in another 2 lectures, so deal with it. Okay, I'll see you guys.